Welcome back to our channel. Today we are going to discussing about the linear algebra model problems. So given that A and B are n by n matrices, so A and B are n by n matrices. So at the given BA plus B square which is equal to I minus BA square, then which of the following are true? That is the question. So option A is B is non-singular. We know the fact what is non-singular, and non-singular means the determinant cannot be non-zero. So which is A plus B determinant non-zero in the sense A plus B is non-singular. The another word of non-singular will be invertible. You have to know the words. So another word of non-singular matrix will be invertible, and vice versa singular matrices can be mentioned as non-invertible matrices. Yes, so given that BA plus B square equal to I minus BA square, then from this step we get BA plus B square plus BA square equal to I. So minus BA square can be dragged down to the left side, we get the plus BA square equal to I, and then taken out B as common. The remaining part will be A plus B plus A square equal to I. So this is the fact. So taken out B as common, the remaining part A plus B plus A square equal to I. So now taken out the determinant on both sides. So taken out the determinants on both sides. Determinant of B into A plus B plus A square equal to determinant of I. Also we know we have the linearity property. So what is linearity property in the sense? We got to know the property which is non-singular means if a matrix A is non-singular, then the determinant must be non-zero. So this is a usual fact which we learned from the schooling's level as well. So if A is non-singular, determinant of A must be non-zero. That also same the fact determinant of AB equal to determinant of A into determinant of B, but also know the fact determinant of A plus or minus B which is not equal to determinant of A plus or minus determinant of B. So linearity property doesn't holds for addition or subtraction, but the linearity property holds for multiplication along over the determinant. Yes. So now split over the determinants, we get determinant of B equal to determinant of A plus B plus A square. So what is determinant of I? We also know the fact I is identity matrix, so whose leading entries are 1 and other entries are 0. So determinant of I will be, see, also know the fact the product of diagonal elements, so this is a result, so finest result, product of diagonal elements is equal to determinant, but note the fact this property holds only when A equal to D, which means if A is a diagonal matrix of order n, then the determinant value must be equal to product of the eigenvalues. That is a known fact. Yes. Identity matrix means whose leading entries are 1 and other entries are 0. So therefore the product of leading entries must be 1 power n. So which is 1. So where n is the order of the identity matrix. So determinant of I must be 1. Hence we get 1 is the answer. Then we have determinant of B and then determinant of A plus B plus A square equal to 1. The product of two numbers must be 1, which is either B is non-zero and so either both determinant of B and determinant of A plus B plus A square must be non-zero, because if the product of two numbers must be 1, then both numbers cannot be 0. If either one of the numbers must be 0, then the product cannot be 1. The product must be 0. So therefore determinant of B must be non-zero and the determinant of A plus B plus A square will be non-zero. So know the fact if the numbers A into B equal to 1, which is automatically imply that A must be non-zero and B must be non-zero. So this is the simple fact. This is the elementary number theory fact. Use the fact, we get this is considered to be A and the other element considered to be B. So either A must be non-zero or B must be non-zero, which sense both A and B must be non-zero parts. Therefore determinant of B must be non-zero. Hence we get B is non-singular matrix as the right answer. So this is a part B question of CSIRNET. Automatically B, C, D will be eliminated. So this is the easy fact. So we have to know these things as the results part. This is a linearity property along multiplication, and linearity property doesn't hold for matrix addition and matrix subtraction. And if A is a diagonal matrix of order n, the determinant of A must be product of the leading entries. Also know the fact determinant of identity matrix must be 1 power n equal to 1. Yes. And then we have one question for you. Then A equal to 1, I minus 1. So what is the trace of A power A theta? That is the question of this video. A power theta means just A bar transpose, so know the fact. We will explain this problem in the next classes. So hence we conclude the video with this problem. You got to do this problem and then you can post the answer as a comment section, we will discuss out. So as we started the CSIRNET classes in upcoming December 2025 examinations, the classes are going on. If you wish to participate or wish to enroll in this course, you can contact the screening numbers which is mentioned below, or otherwise you got to fill the course description form which is placed in the description section, and share this video with your friends. Thank you so much.